Hello everyone, welcome back to our YouTube channel. My name is 𝗟𝗲𝗃𝗲𝗃𝗲 and I am from Smart Interviews. And as you have already seen in the title, so we are going to solve problems from previous Codechef contest, which is Starters 154. So why to wait? Let's get started. Let's solve the first problem, Coldplay Tickets. Let's see what is the problem. Okay, so let's read the problem statement. Let's say you want to go to the Coldplay concert along with n of your friends and you are buying tickets for everyone. Each ticket costs 5,000 rupees and you have to calculate the total amount you need to pay in rupees. Okay, so input format is first and only line contains in n, which is the number of friends you have, and output format is for each test case you have to print in a new line, you have to print the total cost of all the tickets for yourself and for your friends as well. Okay, so let's say if you have one friend, that means the cost would be 10,000, that is one for yourself and one for your friend, so 5,000, 5,000, 10,000. If you have 5 friends, the total cost would be 5 plus 1 for you, 6 into 5,000, which is 30,000. So it's pretty simple. Let's just quickly take n as the input. Okay, and answer would be n plus 1 tickets you want, and each ticket cost you 5,000 rupees. So print answer. Let's just see that if it works for the sample test case or not. Yes, obviously. What about the hidden test cases? Got it? So this was pretty simple. Let's get started with the second question, which is calorie limit. Okay, calorie limit. Sushil is a diabetic patient. He is only allowed to eat at most k calories in a day. However, he likes to eat sweets a lot. There are n sweets in front of him. The ith sweet has a calorie count of a of I. Sushil will eat the sweets in order. That is, he will start from the first sweet and then the second and then the third and so on. So if eating the ith sweet would take him over his daily calorie limit, he will not eat it. And not just that, he will also not eat any further sweets. Okay, so he'll stop eating the sweets there itself. Find the maximum number of sweets Sushil can eat without exceeding his calorie limit. So input format is first line contains the t, which is the number of test case, and each test case consists 2 lines of input. First line contains n and k, where n is the number of sweets he is having in front of him and k is the calorie limit, daily calorie limit. Second line contains n spaced integer, which is space separated integers, which are the number of sweets and calories of basically each sweet. So let's say for the first test case, he's having 4 sweets in front of him and his daily calorie limit is 10 for now. If he eats the first sweet, he has consumed calorie of 5 units. Okay, still he is under control, so he can eat further. If he eats the second sweet, then the total calorie he has consumed till now is 7, which is still under control, so it's fine. If he eats the third sweet, his total calorie would be 12, which is more than 10. So it is not acceptable. So basically he will not eat any further sweets. The total sweets that he has eaten is only 2. That's why answer is 2. Same for the next test case. You can see 4 sweets is having and 5 is the daily calorie limit. So 2, fine, plus 1, 3, fine, plus 1, 4, fine, plus 1, 5, still fine. So he can eat all the sweets. Next test case, 3 sweets is having, 10 is the daily calorie limit. First sweet is having calorie limit of 11, which is exceeding the daily calorie limit. So he will not eat the first sweet itself, and if he doesn't eat the first sweet, he will not go further also, right? That means the total number of sweets he will have for the third test case is 0. Got it? So let's get down to the code part. First of all, let's take the input. Yes, t equals to take the input and loop over k times. Okay, so now inside each test case we will have 2 things, n and k. So we'll quickly just take them as input. Fine, and then the n sweets, the calorie of n sweets basically. Fine, so the input part is done. Now the logic is very simple. If by adding the current element he is not exceeding the daily limit, that means we can add it. If by adding the current element his daily limit is getting exceeded, we should stop there itself and we should break the iteration basically. So we can say we'll break the for loop. Okay, let's take a for loop for I in range of n, loop over n times. Okay, before that, what all things do we need? We need to know number of sweets he is eating, which starts from 0, and we need to know the total amount of calories he is consuming. Okay, so let's say if by adding the current element in total calorie that he has consumed till now, if he exceeds the k value, so we should break here itself. Otherwise, we should add the number of sweets by 1, which will increment the number of sweets, and we should add the calorie of the current sweet. We should add the calorie of the current sweet to the total calories he has consumed. Okay. Once we come out of the for loop, just simply print the number of sweets that he has taken. Let's try to run and see if it passes the test cases. Okay, there's some issue. Invalid syntax. Okay, oh, my bad. I missed the if condition. 240. Okay, let's try to submit it. Correct answer. Okay, all the test cases passed. So this will be a simple code. Shall we move on to next problem? Okay, add 1 or 2 game. Fine. Alice and Bob play a game. There is an integer x which is initially 0. On their turn, Alice or Bob can choose to increment x by either 1 or 2. The game ends as soon as x becomes greater than or equals to n. Fine. When the game ends, Bob wins the game if the game ends at x equals to n value. Otherwise, Alice wins the game. Cool. Alice goes first and the players alternate their turns. Fine. If both the players play optimally, predict the winner. So optimally means both of them are playing to win. Okay. Input format. The first line of input will contain a single integer t, which is the number of test cases. The first and only line of each test case contains a single integer n, which is the limit for the game. So basically this n which we're talking about. Output format. For each test case, output a new line, the name of the winner, the string Alice if Alice wins the game, or Bob otherwise. Okay, any character lowercase uppercase would be treated as equivalent. So cool. Constraints are only there would be maximum 10 test cases and n value maximum could be 10. Okay, let's see the sample input. 2 test cases. Okay, first one 1. So for this Alice wins the game. Why? Test case 1. Alice can simply increase x by 2 on the first move. Then the game ends since x is greater than or equals to n, and Alice wins because x is not equals to n. So it holds. Basically n value was 1. So if we start from 0 and we increment the x value by 2, so x value becomes 2 and n value is 1. So this condition is true. X is greater than n. Also x is not equals to n. Otherwise Bob would have won. Let's see the next test case. 3. For 3, what is the thing here? Bob is a very simple strategy that guarantees a win. Okay. If Alice does plus 2, Bob does plus 1, thus making x equals to 3. Or the otherwise, if Alice does plus 1, Bob does plus 2, thus making it x equals to 3. In both the cases, the game ends after the 2 turns and Bob wins as x equals to n in any of the case. So this is the problem basically. Okay, we'll try to figure out the logic for it first before writing the code. Let's say n value is 1 initially. Okay, how is Alice winning this position? X starts from 0, right? So what Alice will do is Alice will make it as 2 by adding 2 into it. Either they can add plus 1 or they can add plus 2, right? So he is adding plus 2 directly. Now x is greater than n, true, and x is not equals to n, which is also true. So that's why Alice is winning the game. Correct? But if you take any other condition, let's say instead of 1, if n value is 3, we'll see for 3, 5, 6, 8, and so on. Okay. Now let's say if you are dealing with n equals to 3, Alice will start from either he will make 1 or he will make 2 from 0, correct? If you make 1s, what Bob will do? Bob will make it 3 directly, and the game ends because x is greater than or equals to n, true, and x is now equals to n. That means Bob wins the game. Or if Alice starts with 2, what Bob will do? Bob will add just 1. Here he added plus 2, here he will add plus 1, making it 3. Again same situation, Bob will win. Let's say if the case is for 5. Let's say if the case is for 5. So Alice will start from 1 again. Okay. Bob will make it, let's say Bob have 2 options, right? Bob has 2 options. Bob has either he can do plus 1 or he can do plus 2. Now Bob wants to win, correct? So what he'll do is, if he makes plus 1, the number becomes 2. If he makes plus 2, the number becomes 3. Okay. Now Alice has 2 options. This is for Alice. Okay. Alice can make plus 1 or he can make plus 2. Even if we make plus 1, it is 3, and if we take plus 2, it is 4, right? And same here, plus 1 is 4, plus 2 is 5. So here, see, here directly Bob wins. Okay, so we can leave this part. Next, what about these 3? From this, again, Bob has the chance. He can make either plus 1 or he can make plus 2. If Bob does plus 1, he'll get 4. Now from 4, Alice what will do? Alice will do? Plus 2 directly 6, and Alice will win the game. But they both are playing optimally. That is, they both are playing for winning. So what Bob will do? Bob will not go for this. Not go for this possibility basically. Okay. 3 plus 2 is 5. If he makes it 5, directly Bob wins. Correct? Fine. Now again for 4. So we have already seen that for 4, if the number becomes 4, Alice will win. So there is a chance for Alice to win if Bob chooses plus 1, right? So what Bob will do? Bob will not go with this. Bob will just reject this option. Let's see for plus 2. If he does plus 2, we'll go to 3. Then Alice has the chance, and plus 1 means 4. Again from here, Bob will do plus 1 and 5, and Bob wins. Or 3 plus 2, 5, where again Bob wins. So if you do the same thing for 6 and 8 and any number, you will realize that if they are playing optimally, other than n equals to 1, there is no other possible n value where Bob can lose the game and Alice can win the game. If you continue this for 3, 5, take any random number, try all the possibilities you can, but you will realize that okay, in all the possibilities only Bob is winning except one, which is n equals to 1. This is our logic basically. So what we'll do, we'll go back to our code and we'll try to use the same logic here. So t equals to input for range of t, n equals to int of input. If, now what is the condition that we discussed? If n equals to 1, print Alice. So print Alice if n equals to 1, or print Bob, not or, else print Bob. If any other number other than 1 is there, print Bob, or else print Alice. Simple. Let's see. Okay, we are getting the correct output. Let's try to submit it. Accepted. That works. Okay, so it was not really creating another game table and so much big things. It was a small observation that you could have done easily. That's it, right? Let's go to next problem. GCD and XOR. You are given an array of size n. You can perform the following operation as many times as you want, possibly 0. Choose the integers L, R and X such that L and R are in the range of 1 and n, and X is in the range of 1 to 2 power 30, which is basically, they can say X is an integer. That's it, any integer. and do any one of the following. For all L less than equals to I, basically for all I value which lies between the range or within the range of L and R, set AI to XOR between AI and X. Okay, this denotes the bitwise XOR operation. Yes, got it. For all same thing, I within the range of L and R, set AI to GCD of AI and X. Okay, so either what you can do is, there is a list, suppose, okay, there is a list and you chose some L and R somewhere in the middle of array. What you can do is, all the elements between this L and R, either you can set all those elements to AI XOR X, which is X is some random integer value which you will take, or you can set this AI, these elements, array of I, to array of I and X, the GCD of both of them, basically. Okay, got it. That is, choose a subarray of same thing. Choose a subarray of A and integer X, and either replace every element with the subarray of its GCD with X, or replace every element of the subarray with its bitwise XOR with X. Fine. Compute the minimum number of operations required to make all elements of the array equal to K. Got it. Okay. So input format, the first line of the input will contain single integer, same thing. Each test case consists of 2 lines of input. First line of each test case contains 2 space separated integer, which is n and k. The k, that is the element that you have to make equal to all the array elements should be equals to k. That is one input, and n is basically the number of size of the array, basically. Second line contains n space separated integer, which is a1, a2, and so on. Output format, print the minimum number of operations in one line. Okay, so constraints are t is less than equals to 10 power 4, n is 2 into 10 power 5, k and array of I lies between integer range, basically we can say. The sum of n across all the test cases does not exceed 2 power 5. Fine. Let's see the sample input output. 3, 4, 2, 2, 6, 4, 1. Okay, so 4 number of elements are there in the array, and 2 is the number that you have to make each element equals to in the array, and you have taken a minimum of 2 operations. Let's see how. We can do the following operations. Let's say choose L equals to 2 and R equals to 3 and X equals to 2, and the GCD operation. Okay, this turns array A into 2, 2, 2, 1. Okay, so he's telling that if we take 6 and 4, so and X equals to 2, the GCD, the greatest common divisor of 6 and 4 is what? 2. So they will turn these elements into 2. So the array will become 2, 2, 2, 1. Then they will choose L equals to 4, R equals to 4, which is the last element, and X equals to 3, and the XOR operation. So if you do 1 XOR 3, the answer would be 4. Sorry, if you do 1 XOR 3, the answer would be 2. So you will change the array into 2, 2, 2, 2, which is all the elements of array became equals to k. So minimum of 2, minimum operation is 2 operation. It can be proven that it is impossible to make all the elements equal to 2 in fewer than 2 moves. So this is the optimal. Yes. Test case 3 is given. Okay, what about test case 2? 1, 3. Okay, so there is single element, and that single element is equals to k, so we don't have to worry about it. Okay, so this is one edge case that we can use. 2, 2 elements, and you have to make all of them as 2, and 4, 8. So as you can clearly see that the greatest common divisor of both of them is, if we take X equals to 2 and 2, 4, GCD of 2, 4 would be 2. GCD of 2, 8 would be 2 again. So if we just make them X equals to 2 and if we just do the GCD operation, in single operation we can make both of them as 2. So that is our logic. Okay, so we'll discuss in the one note what all we have discussed so far. So let's say we have written all the thing here, and first of all let us look at the second test case for which the answer was 0. So we can clearly say the answer is 0 for the test case where all elements in the array are equals to k. correct? That is one test case. Or we have got 2 for the first test case and we have got 1 for the third test case. Let us take this test case 26441. So first element is already 2, so we don't have to worry about it. We have to take care of the rest of the elements, right? 6, 4 and 1. Now out of these, what they have done is 6 and 4, they know that we can make 6 and 4 as 2 with the help of GCD operation, correct? And the rest of the element can be used, can be converted into 2 using the XOR operation, correct? So we have only 2 operations with us, GCD and XOR, correct? If we have to apply both of them, the answer is going, 2 or more than 2 basically. And if any one is working, this will give us one answer. For example, you can see the third test case. We know that 4 and 8, we can make both of them as 2 using only GCD operations. So that's why the answer is 1 only. So what we have to see here is now that answer is 1 sometimes 2 and sometimes so on, right? So before moving forward, I want to ask you a question. Let's say if I give you some random array values 5, 8, 2, 91, 80, 57 and so on, any random value, and I want you to convert all the elements into, let's say, 2. Okay, can you tell me manually what will be the answer for this? How many operations will you take to convert all the elements in the array into 2? I'll tell you. The best option here is this GCD function, this GCD operation. Why? I'll tell you. See, all the elements, if somehow I'm able to make 1, suppose if all the elements I'm able to make 1, can I do XOR operation on this array and make all the elements equal to 2? If I do XOR with 3, with anything basically, which will give me the desired value, I'll get 2. All the elements can be set to 2, correct? So the observation here is that take any number. Can we do something like array of 5, 1 GCD, set array of 5 to basically its GCD with 1. Answer would be 1. Set all the things to 1 and apply some XOR value. But this is only applicable when we can't do single operation to get the answer, just like we did in test case 3, right? So this is one observation. So can I say that at most the number of operations that you will need will be only 2 operations at most, and minimum is 0 operation. So now our answer lies in the range of only, let me just put it away. Now my answer lies in the range of 0, 1 or 2. When the answer would be 0, when all the elements is equals to k, correct? When the answer would be 1, in case where only one of the operation is required to take care of converting all the elements into k. For example, the third test case. So either there would be a test case where only GCD would work or only XOR would work, and then there will be a test case where you need both of them to convert. So first of all, what do we want? We want the range of the elements that we need to work on, because see, why would you work on 2, right? It is already equals to k. So first of all, we have to find the starting index and ending index of that range on which we have to work. Suppose we got one start index and one end index. Then we have to loop over start and end, and we have to see that if I perform GCD on this, will it convert into k, or will if I apply XOR operation on this, will it convert into k or not? Okay. Now how to check this part is simple. If I do GCD of this element, and this part is actually very simple. If this element is divisible by k, that means I can apply GCD easily. So that is one condition. If array of 5 is divisible by k, then GCD will work on it. So let's say we'll take care of the test case where it is not equals to 0, where we cannot apply GCD. Okay, GCD cannot be applied. If I'm applying XOR, all the values XOR should be same, right? All the values XOR should be same. So let's say if array of I XOR with k, if it doesn't give the value which I got the value while I perform any element XOR with k, let's say if I do array of start, okay, XOR k, if I don't get this values same, then I cannot apply XOR as well. Understood? So I cannot apply XOR as in I need GCD as well here. Fine. So we need both of the operations in such case. So we need GCD and we need XOR, both of them to solve the problem. Same logic. Let us try once if it is working in the code or not. Okay. Okay, done. Let us write the code. First of all, the input part. N comma k equals to map and then take the done. Now what we discussed, first of all we need to check how many elements in this array are there which are equals to k. So let's take a count variable initially 0 for x in array. If x is equals to k, count increase to 1. Done. Now if count is equals to n, that all the elements are k, why would you even do anything? Print just print 0 and move on. Else if it is not the case, then what we have to do is we have to check how many elements are different than k and what all operations can we perform on this basically. So let's take first of all end and starting index as -1, okay, and let's take the first element which is not equals to k and the last element which is not equals to k basically. So for I in range of n, if array of I not equals to k, start equals to, start will change only first time when if start is equals to -1, then only change start. That is start should only change for one time. Start is equals to I and end will change every time we get a new element, okay. End equals to I. Then after this, now we have to loop over start and end. So let's say for I in range of from start, okay, till n plus 1, that is including the last index as well, we need to check two things. Can GCD take care of this range or can XOR take care of this range? Let's say that initially we say yes, GCD and XOR both will take care of this situation, okay. Let's put it out. Then if at any point we saw a number or we saw an element which when divided by k does not give 0 as remainder, which is it is not divisible by k, we can directly say that no, we cannot rely on only GCD for converting this range element into k. And if we saw any element which when XORed with k value, it is not equals to the any element in this range, XORed with k, okay. So we can say yes, if this is the case, XOR is also false simply. Done. Now we'll check, do we need both of them to convert the entire array into k or do we need only one of each. So if they both are true, right, or if any one of them is true, we can just say that print 1, that is maybe one of them is true or both of them are true and all. Or if both of them are false, that means there is an element which needs XOR and there is an element which needs GCD. So we can just directly say okay, you need at least 2 operations to perform this, and yep, this would be your code. Yes, this is your entire code. Let's okay. Let's try to submit it. Successfully executed. We got 201. Let's try to run it. Sorry, let's try to submit it. Accepted. Understood? So basic observation was you don't need 200 or 300 or 100 operations to do. Only maximum would be 2. Minimum would be 0. 0, you know, that is very pretty basic test case. 1, when either GCD will work or alone XOR will work. 2, if you need both of them. Both of them how? If there are very random elements, just make it 1 using the GCD operation, and at the end just use some required XOR value, convert it to K. That's it, simple. So yeah guys, this was regarding Starters 154. Do let me know if you learned anything new here, and do follow us, do share this video with your friends, and do let them know that we are solving coding contest problems and also. And there are other coding contest problems also on our page, which you can just visit and you can check, and we will be doing further coding contest problem as well. So yeah, subscribe and click the bell icon so that whenever we post a new video, you get the reminder, you get the notification. And yes, that's it. Thank you for watching guys, and yeah, don't forget to like, share, comment and subscribe. Thank you.